Welcome to Mickey's Study Circle channel. In this video, we shall see how to do the computer drafting of the orthographic projection of solids using the Solid Edge software. Coming to the problem statement, we have a cube of 40 mm side which is resting on HP on an edge which is also inclined to VP at 30 degrees. We need to draw the projection when the lateral square face containing the edge on which it is resting is making an angle of 50 degrees to HP. So looking at the problem statement, we can understand that the type of solid given to us is a cube. So a cube is nothing but an object which is having the length, width, and the height all equal to the same dimension. So here it is equal to 40 mm. Next is the resting condition. So as per the problem statement, it is resting on one of its edges. And also this edge is inclined to VP at an angle of 30 degrees. So we can understand that it is a non-beta angle problem. And also it is making an angle of 50 degrees with respect to the HP. That is the lateral surface, that is the edge from which it is resting, and the lateral surface from the edge on which it is resting is tilted with respect to the HP at an angle of 50 degrees. So we can just assume that the axis which is also parallel to the lateral surface will be inclined to the HP at an angle of 50 degrees. So with this data, now let us see how to draft the solution for this. So let us begin by selecting the line option. Let us select a continuous line of thickness 0.18 mm and draw the line, and then annotate the line as X and Y, indicating that it is a reference line. And also let us annotate the reference planes as HP and VP. So now let us draw the top view of the cube. So now let us consider a line of thickness 0.50 mm. So in the top view, the cube will just look like a square. So we can select the rectangle option and then complete the cube by drawing a square of 40 mm cross 40 mm. So this is the top view of the cube. So let us just move this. Let us draw the diagonals of the cube to get the point from where the axis shall originate. So select a line of thickness 0.13 mm. So the point of intersection of the diagonals is where the axis will originate. So from here we need to draw the axis of the cube. So we know that the axis of the cube will also measure 40 mm. So let us draw a line of 40 mm and the line be a type of chain line. So this is the axis of the cube. Now let us complete the front view of the cube. So select a line of thickness 0.50 mm and let it be a continuous line. So before we draw the front view, let us draw the projection lines from each of the corners of the cube and then intersect it with the XY line. So let us complete the front view by connecting the end points of the projection lines. So this completes the front view of the cube. So before we move on to the next position, let us annotate the views. So we'll assume that the cube is resting on the edge A1, B1 and the top face will be A and B. So now we have completed the annotations of the top and the front view of the cube. So now let us move on to the second position, so which tells that the cube is resting on A1 B1 edge and that lateral surface, that is A1 B1 AB. So that is the lateral surface of the cube on which it is resting, and that is inclined to HP at an angle of 50 degrees. So we need to understand that if this face is inclined at an angle of 50 degrees, even the axis will also be inclined at an angle of 50 degrees. So keeping this concept in mind, now let us understand that we need to tilt the cube in such a way that the base of the cube is tilted at an angle of 90 minus 50. So now let us select the front view of the cube and then tilt the cube in such a way that the axis is inclined at an angle of 50 degrees while the base of the cube is inclined at an angle of 90 minus 50, which is equal to 40 degrees. select the base of the cube and then enter the angle of rotation as 90 minus the angle of inclination of the axis, which is 50, and then tilt the base at this angle. So this is the angle of 40 degrees. So you can just use the extend to next option, extend the axis line to meet the HP or the reference line, and then show the angle of inclination, which is equal to 50 degrees. Now we shall complete the top view of the cube when its lateral surface is inclined at an angle of 50 degrees. So you can just see this, the angle of the lateral surface will also be equal to 50 degrees. So now we shall construct the top view. So draw the vertical projection lines downwards. So from each of the corners and also from the axis point, let us draw the projection line will be the dotted line. So select the dotted line of thickness 0.50 mm and then let us construct the dotted line. So this point of intersection that we get here, and to this point of intersection the line will be the hidden line. Use the trim option to trim the projection line beneath this hidden line. So now we will construct the outer edges of the cube, which is shown by the continuous line. The hidden lines will be there from here to here also, but however it will be overlapped by the visible edge lines. So this is the top view of the cube when its axis or the lateral surface on which it is resting is inclined to HP at an angle of 50 degrees. Now let us complete the annotation of the top view of the cube. So this face is the top face which is visible to the observer. So this is the corner A, this is the corner B, and this is the corner C, and this is the corner D. While this is the corner on which it is resting and it is tilted. So this is the corner A1, while this is the corner B1, this is the corner C1, and then the corner D1. We can also indicate the axis line. So just use the trim option, select the line, and then select the center line of thickness 0.13 mm. So connect O1 to O to indicate the axis line. However, the projection line can be connected by using the extend to next option and annotate the axis line as O and O1. So with this we complete the top view of the cube with its lateral surface on which it is resting is inclined to HP at an angle of 50 degrees. Now we need to go for the next position, that is this cube is also inclined to VP at an angle of 30 degrees. And which parameter is inclined? The resting edge on HP is inclined. So we need to take the cube from the second position and incline the edge A1 B1 at an angle of 30 degrees to the VP and then complete the front view. So for that, first let us draw the line inclined at an angle of 30 degrees so that we can place the cube. Draw a line of inclination minus 30 degrees so that we have got the reference line to place the edge A1 B1. So this was done only to ensure that the upper face of the cube will not be going beyond the XY line. So now let us select the top view of the cube, select all the outer edges and the inner edges along with the axis, and then annotations also. So now let us move this, ensure the copy is on. So keeping the corner A1 as the reference, place the corner A1 on this 30-degree line. Now use the rotate option and rotate the edge A1 to B1 on this 30-degree line. Use the trim option. You can just trim these lines to avoid any sort of confusions. So now let us draw the projection lines to complete the front view of the cube. So select the line of thickness 0.13. Let us draw the horizontal projection lines first. So we'll complete the top view of the top face of the cube. So let us draw the projections from the corner A and intersect with the horizontal projection lines from the corresponding corners. So A and B is done, and then we'll go for C and D. Use the trim option to trim the projection lines which is not required for the constructions. We can also join the axis point, that is O. So if you just look at this, the farthest corner point for the observer is the corner A, and all the edges running from the corner A will be the hidden lines. So now let us complete this. Select the dotted line or the hidden line, and then select the thickness of 50 mm. So from A to corner D will be hidden, and from A to corner B will also be hidden, and similarly from A to A1 will also be hidden. So we'll complete that in the next step. So now we'll complete the bottom face of the cube. So select the line of thickness 0.13 to draw the projection lines. So we shall draw the projection lines from A1 and B1. So the corners A1 and B1 shall lie on the XY line itself, and then draw the horizontal projection lines from corner D1 and C1, and also from the axis point O1. So D1 is here. From the corner C1, intersect the horizontal projection line. From O1, intersect the horizontal projection from O1. Use the trim option and trim the projection lines which is not a part of the construction. So now we'll complete the bottom face of the cube, so which is completely observable, that is completely seen by the observer. So from A1 to B1, B1 to C1, C1 to corner D1, and D1 to corner A1. So now we shall draw the outer edges. So we shall connect D1 to D, and then C1 to C, B1 to B. So now A1 to A1, A to A1 will be the hidden line. So this is A and this is A1, it will be the hidden line. So this is the front view of the cube when it is inclined to VP on the resting edge at an angle of 30 degrees. So you can just show the angle which is equal to 30 degrees. So now let us annotate the front view of the cube. So this is corner D, corner C dash, this is D dash, and this is the corner B dash, corner A dash, corner A1 dash and corner B1 dash. So let us connect the axis points. Select the center line of thickness 0.13. So from O1 to O, this indicates the axis of the cube. So we shall annotate. So this is the point O dash and this is the point O1 dash. So with this we complete the front view. Now let us just use the leader option to indicate the direction of the projection lines. So with this, we complete the drafting of the solution for the given problem statement. So to sum up the problem, we have got a cube of edge length 40 resting on HP on one of its edges, and here that edge is A1, B1. So this is the top view of the cube, and then this is the front view of the cube. So the axis length will not be given for the cube because it is well understood that the length, height, and the width of the cube will be equal, and all the dimensions will be equal to 40 And in the second position, it is clearly stated that the lateral surface from the edge on which it is resting is inclined at an angle of 50 degrees, which also gives us a clue that this face and the axis line are parallel, and hence the axis will be inclined at an angle of 50 degrees. So to ensure the axis is inclined at an angle of 50 degrees, we are going to incline the base of the cube at an angle of 90 minus 50. So this angle will be equal to 40 degrees. And hence we complete the front and the top view of the cube. So here the farthest corner points are B1 and A1. So we have got the dotted lines here. And next he states that the edge on which it is resting is also inclined to VP at an angle of 30 degrees. So we are going to incline the edge on which it is resting at an angle of 30 degrees and then complete the top and the front views. With this, we complete the problem statement. Thank you all for watching.